is the interpreted programming? Okay, interpreted programming language means interpreter is a mediator which converts the high level language to the high level code to the low level code. High level code is code which is written in the English. Low level code is a binary language. That is what I said you over here. The mediator will be there. This mediator will be either compiler or interpreter. So the interpreter is works as a mediator in the Python. Now you may ask me, now what is the language which uses the compiler? See, the compiler languages are C, C++, Java, all this comes under the compiling language. Now interpreter language, the Python, okay, Python, JavaScript, Python 3.x, this all comes under the interpreter language. Now, what is the difference between like an interpreter and a compiler? See, if you take it as a compiler, what it will do is like it will first, now any interpreter or compiler, there will be two things they will be doing it. One, it will check for the error. And second thing, it will execute the code. Two things. Any program, any interpreter or the compiler will do the two things. One is check for the error and execute the code. Now, if you check it out over here, I'm removing this part, okay, and I'm running it. It is giving me an error. Now, this error, I got the error. Now, who is checking this? Who is checking this? This is done by the either compiler or interpreter. Okay? Compiler or interpreter will perform two things. One is, one is the check for the errors, that is syntax errors. I will put it as syntax errors. Second one is it will execute the code. That is, after checking the errors, if there is no errors are there, it will execute. Now, what is the difference between a compiler and the interpreter? See, if you take the compiler over here like this, this is my compiler. And this is my interpreter. Just take it. This is my compiler and this is my interpreter. Now, compiler and interpreter. Now, this is the code. This is the code I'm writing over here. Sorry. One, 2, 3, 4, 5, 6, 7. So like this. Here, this is our code 1. Okay, this is a code 2 over here. Okay, code 2. Now, in this code, we are using the compiler. And in this code, we are using the interpreter. Now, what is the purpose of them? First thing is it will check for the error and execute the code. Now, execution of the code is nothing but it will convert the code from the English-like language, high-level language to the low-level language. That is what it will do. Execution of the code means high-level language to the low-level language. Nothing. Now here, see this, what it will do is like first, how the compiler will work is, first it will check for the error for this one. Second, it will check the error for this one. Third, fourth, fifth, sixth, something. After this, if there is an error is there in this, then entire program is terminated. You will not see any results. Now, in this case, if this code is checked for the errors and this will be executed, that is, you will see the output. If this code is checked, after that, it will be executed. Then third line is checked, again, this is executed. This is done and this is executed. Suppose there is an error is there over here. Here the program gets terminated, but you will see the results of the before. That is the advantage of the interpreter, and that is how the compiler. Here, there is a slight drawback is there with the interpreter. What is the drawback is interpreter. Okay, the interpreter will execute line by line. It will check for the error and execute, check for the error, execute, check for the error, execute. So because of each and every line, it is a bit slow. Whereas this one compiler, it will check it all the lines for the error first and then it will execute. Because of that, it is fast. Now this is the drawback. This is the drawback between the Python and the other programming language. So when interpreter, now interpreter is used by the Python. So obviously whatever the drawback is there, that will be implemented applicable for the Python also. So now the question is, what the Python 3.x, the latest version of the Python 3.x people did it is, they made a, because this is the advantage. This is the advantage for the compiler, and this is the disadvantage for the interpreter and the Python. So what the Python people did it is, they created a interpreter. They call it as interpreter or PVM. PVM, Python Virtual Machine. In this, what they put it is, they put a compiler and they put an interpreter. Both they put it. They put a compiler and they put an interpreter. Okay. Now, so the interpreter and the compiler both are, interpreter and compiler are both is blend together in a one single pack kind of stuff, which is called as PVM. Now, what the PVM will do is, see, this one is executed by compiler alone. This one is executed by the interpreter alone. Now, what this one will do it like, if this is executed, the compiler and interpreter both will work, or this one executed, the compiler and interpreter both will work. So what is that I want to say it is, if there is a work is there over here, here only compiler is working. Here, if there's a task is there, only interpreter is working. But in this case, the interpreter compiler both will be working on a code. Obviously, the two persons who are working on a single task will be faster in completion compared to that of any one person, right? That is the advantage of the PVM. PVM stands for Python Virtual Machine. This is a combination of compiler plus interpreter. Because it's a combination of two, then it is much faster than your compiler. This is much faster than your compiler. This is the biggest advantage of your PVM over here. This PVM is there with the Python 3.x guys. 3.x, not in the 2.x. This is there with the Python 3.x. Now, henceforth, whenever I'm talking about the interpreter, I will say that interpreter is coming, interpreter is executing. That is nothing but I'm trying to say that it is a PVM. Now, PVM is what? It is a combination of compiler and interpreter. Now, what is the difference between interpreter and compiler? Actually, compiler will first check for the errors, the entire code, and then it will execute it once. But whereas the interpreter, what it will do? It will do the line by line execution. It will do the line by line execution. Now, because of this, because we are using the blend of compiler and interpreter, this is very fast compared to the compiler. This is the major advantage of your interpreter and the PVM over the interpreter. Now, next one is, now this is about the interpreter, and now next one is OOPS, object-oriented programming language. Okay. Now, again, there is a lot of confusion is there about this language, guys. This is OOPS. OOPS stands for, actually OOPS stands for object-oriented programming structure. Object-oriented programming structure. Okay. Now, what is the use of the object-oriented programming structure? Why we have to use it? See, actually, I told you in the starting of the data science, this concept was introduced in 1960. And it was because of the AI, because John McCarthy came up with the AI in 1956. And 1960, the people introduced the concept of, oops. Now, this where what will happen is everything, all the programming will be dealing with the object and the classes. Now, what is object? What is classes? We are going to deal with the Python, while when we deal with the OOPS. But as of now, in a very broad view, this is a paradigm. This is called as paradigm. What is the paradigm, guys? Paradigm is nothing but a style of writing the code. A style of writing the code. Okay? Paradigm is nothing but it is a style of writing the code. Okay. OOPS is an object-oriented programming structure that is nothing but it is a style of writing the code. Now, why we want this? Is this the only style? No. There are multiple paradigms out there. One is called as procedural. Second one is called as functional. Third one is called as, modular. Fourth one is called as OOPS, and fifth one is called as modular. Now, these five are supported by our Python. All these five is supported by our Python. What is the procedure? Procedure is a simple, very simple way of writing the code, like this. We wrote the code starting from the left, going towards the right, starting from the left, going towards the right. Like this, we will write the code. This is called as, a procedural paradigm. This is called as procedural paradigm. Procedural paradigm. So now, in a simple way, I will show you. So in this, we will write the code one line below the other. There is no particular structure, no up and down, very simple coding it is. Okay. Then next one is what is called as functional paradigm. See, in a procedural paradigm, we will write the code like this, guys. Okay, just take it. This is the code is there. You will write the code like this from left to right, one line, two line, 3, 4, 5, 6. Like this, you are going to write the code over here. This is the way you will write it. This is called as procedural paradigm. Okay. Now, what is the major disadvantage? This is a very simple one. Now, what will happen is if the compiler or our PVM interpreter will come over here and we will check the error and execute. This one, this one, this one, this one, it will go and execute. Suppose I'm having 1,000 lines. All the 1,000 lines, your PVM has to stop and execute. Suppose in these 1,000 lines, there are a set of 20 lines are there, which is repeated 10 times. A set of 20 lines, a block of 20 lines is there that is repeated 10 times in your entire code. That is, here there is a block of 20 lines is there. Okay. Then here you have a block of 20 lines is there. Again, here there is a block of 20 lines is there. Here there is a block of 20 lines is there. And here there is a block of 20 lines. Now the same lines are repeated. Now with this, what happens is you are wasting your resources. Why means your interpreter will execute this one. Your interpreter will execute this one. Your interpreter will execute this one and compile and say it will check for the errors and execute. It will check for the errors. It will check for the errors and execute. Actually, they are all same code. We don't need to check for the errors each and every time. But still, in the procedural programming, it is the problem for us. We are going to repeat the things will be repeated. We don't have a concept of reusability. To avoid this one, what we do it is we will do it with a functional or the structural programming. What the structural programming is, first we will identify this repeated code. This repeated code, I will put it at the starting over here like this. I'll put on this starting code. This is where I will put on our code at the starting. And after this, what we'll do it is, we are now, now I'm writing the code over here. Just take it. The normal code is there over here. Now this is the repeated lines. Okay, these are the repeated lines. We put a block at the starting over here. Now what happens? I will give a name to this as ABC. Now this one I want it over here. I will call it ABC. Now from here it will go and it will execute and it will come down. Now then again here I wanted ABC. I will say that ABC, it will go and execute and come back over here. Again I wanted ABC over here like this. Now if you wanted 20 times, 30 times, 40 times also, you have to call that one. But how many times you wrote the code? Only once. Okay, only once you wrote the code. And how many times you are executing? N number of times. This is called as functional programming. Why it is important is reusability. Reusability is a major reason why we go with the function. Now, a simple example you take it. Here, if there is 10 places, 20 lines are there. Now, I want to add the one more line, that is 21st line. How many places I have to add it? 10 places I have to go and add it. Okay. Now, while adding, I did a mistake. Then how many places I have to go and remove that error? 10 places. This is a really painful process. Okay. Now, in this case, because all that repeated lines are at only one place and we are calling them n number of places. Now, how many, if I want to add a new line, I have to add it only here. That's it. It will be implemented everywhere. Now, if there is anything, what you call it as anything debugging, I have to do it. I have to do it only at this place. Then all of places it will be implemented. This is the advantage of your, your functional program. But here the problem is this code, whatever the code is, the repeated code, I can reuse it in the same program only. Now we are working as a team. We are 10 people, we are working as a team. Now these 10 people, what has happened is I wrote the code. I wrote the code as a team leader. I wrote this code. I kept it at the starting of my program and I'm using it in my code. But if you people want to reuse it, we can't do it. We can't do that. So now how I can give you all also, you can reuse that code is, that is called as modular programming. Okay, that is what is called as modular programming. What you are going to do it is modular programming. In our functional programming, this is the code. In the coding, we are going to identify a repeated code and we will keep it over here. Okay, and this I will repeat it. I will call it ABC, ABC, and ABC over here, which will call over here. But in the modular programming, what we are going to do is this code, whatever is the repeated code, I will put it in a separate program. A separate program, I will put it like this. Now from here, I'm going to call this. Okay. Now this is accessible to all. If my another team member is there, he is the one. And there is one more team member is there, he is the one. These are the different team members. So what will happen is these team members will can use this. Now, these people also can use it. So the same code which I have written it, previously I was using it by myself only, but in this case, we are making it available to all the others. This is what is called as, modular programming or paradigm. Modular paradigm. This is what is called as modular paradigm. Okay. Now this is what is called as modular paradigm. Now let's see that what is a oops now. Oops is nothing but this is your function, right? In a simple way, I'm not talking syntactically, guys. This is my functional programming. In the functional programming, we will identify the repeated code and I will put it at the starting. Okay. like this I'm going to do. Now this is the repeated code, and I want to use it over here ABC. I will call it ABC. I will call it over here. Now when we go to the oops, we will put this code in a one more layer of protection. This is called as a class, and this is called as a method, which we call it as function before. Now we call it as method. Now, these are big concepts, guys. These are really big concepts, which we are going to learn it one after the other in the future. What is functions? What is modular? What is the oops? Everything we are going to read. This is a very broad view. Okay. Now, this is the class and extra layer of protection we will do. Why we need the oops? See, oops is required because of two things. One is, first one is reusability, reusable, and second one is security. This is an extra level security. Because of these two concepts, the oops is very popular, and remember that the oops is the, if you have the oops in your resume, that itself is a qualification. Second thing is that without knowing the oops, we can't build the applications. Oops and the modular programming is very important, and with the combination of oops and modular programming is really amazing. That is, in a simple way, this class and the object, I will take it and put it in a separate file, and it is accessible to all the others. This is the advantage of your modular programming. Sorry, oops programming. And what oops and modular. Now, if you take it the logical, now logical is nothing but you're not going to write the code based on the program. No, based on the task, you're not going to write it. You will write the code based on the formula. I told you, right? If you have the Python with formula, this is called as what? Model. This model, we are going to use it in our data science. This is a very amazing concept of writing the code based on the formula and can be used whenever you want it. This concept is called as, logical programming. All these things we are going to see it, guys. While doing it, I'm going to explain this one again with the history and everything. So this is what all about the basic introduction of your Python. And tomorrow we are going to quickly look at the what is a dynamically typed. Dynamically typed is a very big concept. It is a very powerful concept. We will see it as we go deeper down into the Python. Tomorrow we will quickly see the history and especially the difference between the Python 2.x and Python 3.x. And then we will start writing the coding, how we have to do it, and I will show you how to do the installation.